Recording and perfect. All right, welcome to our webinar. This is one of the this is the first of the webinars that we plan for the very next future, and it's actually a very joint and very joint forces webinar for three Prima projects. The Nexus project, one Section 2 project, one Section 1 project, FrontAg Nexus, CIPROMED and Advagromed. And this webinar will lead you to the magic and fascinating world of insect farming and aquaponics. How these two are connected? We have our very good speakers here to show you which way to go. So without further delay, we will start with the first speaker, and who is going to talk about the future, like with the creative Feed the Future title. Sarah from Sarah Odon from University of Torino, researcher from University of Torino. She will be talking about the insects for food, feed, and waste management, which is an often neglected part of the whole insects for food and feed production. Feed the future. So, Sarah, the floor is yours.
Thank you. I'm going to share my screen. Let me know if you can see.
Yes, perfect.
Perfect. Okay. Thank you very much. Good afternoon, everybody. I'm Sarah 𝒊𝒏𝒔𝒈, a researcher of the University of Turin, and I work with insect from almost 6 years. I work with insect and also the application of insect as feed. So today I will speak about all these topics. I think it's a large argument, so I will try to do my best to focalize on all the essential aspects. So obviously, probably you already heard about insect more in the application of food than feed, but these two aspects are strictly connected. It is important to underline that consumer likely more the utilization of insect as feed than directly start to use insect as food. But what is this connection? If we consider the main animal products that we consume, that is, for example, poultry or meat or eggs or fish, we have to consider the quantity of feed that we use to produce this amount. For example, if we focalize on fish, we can see that the quantity of fish that we consume is almost 93 million tons. And to reach this quantity, we need almost 1.1 kilos of feed per each kilo of fish that we obtain. That is a large amount. And inside of the feed that we use for grow our animals, the protein ingredients are the ones that are more expensive and has an important impact in terms of environment. So the chain between food and feed is related also to these aspects. And these protein ingredients are, for example, the soybean meal or the fish meal. If we start to speak about the soybean meal, we have to look for the cost that now we have to buy these products. And we can see that the price increased over the time. This is the reason why the reason is that the Chinese market start to increase their demand of these products, and this has an aspect on the price. And an important other aspect is that the soybean production, as you probably know, is one of the main causes of deforestation. So if we compare the soybean meal production with the insect meal production and the protein that we can obtain from these two kinds of production, we can see that if we start to if we obtain, for example, for 1,500 meters square of soy, the protein quantity is the same that we obtain from 1 meter square of insect. So we can increase the production of protein through insects. And if we think about the fish meal derived from fish waste, but also the small fish that are fished during the fishing operation. And all these waste and byproducts are obviously not used for human consumption, but are anyway fish that are inside of our marine ecosystem that is damaging over the time. And also in this case, the price is increasing due to the slowdown of the production of the Peru. So the idea is to use insects that has an important role in nature. They are able to bioconvert the waste and the carrying organic matter, and we would like to use insect as with the same process on our agri-food byproducts. And to obtain these and to make the insect really applicable to the circular economy, we have to consider all the cycle of our insects. So we can use organic waste or byproducts to grow our insects. And then we can use the larvae or the other insect, for example, the cricket itself has a food ingredient or has feed ingredients. And then at the end, we can use also the byproducts of the production, that is the frass, the digestive substrate, as soil fertilizer in our soil to improve the quality. But what are the insects that actually we can rear? And there is an important difference between food and feed production. In this slide, you can see all the insects that are actually authorized for feed production, and some of them are used also for food. The two main ingredients, main insects considered for feed production are black 𝒊𝒏𝒔𝒈 or Hermetian lucens and yellow mealworm, telemer molitor. And the other, for example, crickets, are mainly considered for food production due to their management and also the substrate that we use to grow them. If we consider the feed chain, it is important also to underline what are the substrate that we can use to rear our insect, and as consequence, what are the insects, the animal species in which we can use insects. The first part, so the substrate that are actually authorized are vegetal substrate, farmer feedstuff, and we consider also the indirect animal products such as the dairy byproducts or the eggs byproducts. We cannot use, for example, manure. We cannot use substrate that includes, for example, meat or fish. And as concerned the animal target species, we can use insects in pets, in aquaculture, in poultry, in swine. And as if we consider also the lipid fraction, we can use it in ruminants diets. So we have a large amount of animals in which we can use these kind of insects. I would like to underline the two main insect species that are actually under the attention of the research, but also of the industry. And the first is the black 𝒊𝒏𝒔𝒈. The black 𝒊𝒏𝒔𝒈 is a species native to South America, but today has a cosmopolitan diffusion. It is very able to convert waste or byproducts, and we have to focalize the attention on the kind of waste in which this insect can grow, both dry and wet waste. It means, for example, beer byproducts or eggs byproducts, but we can use also cereal byproducts. It depends on the mixture of waste that we can use. And the other aspect is the life cycle management that is quite easy, and the life cycle itself is quite fast, 30 days from adults to adults in the environmental condition that you can see in the slide. And as concerned yellow mealworm, in this case, the species is native of Europe, but also in this case, the diffusion is cosmopolitan. The efficiency is quite high compared to black 𝒊𝒏𝒔𝒈, but we can use only dry substrate because usually this insect infest our cereal production. The life cycle management is also quite easy, and the development time is quite longer. If you consider all the cycle, the period is of 100 days, 110 days to the environmental condition that you can see also in this slide. But at the end of our cycle, what are the insect-derived products that we can obtain? Obviously, there is a difference in relation to the insect species. If we think 𝒂𝒂𝒏𝒊𝒄𝒔 or yellow mealworm, we have a larva stage, so we can obtain the meal from the larvae. In the case of cricket, we have the nymph, and we can use the nymph as a main part from which the insect-derived products derived. But if we focus on �𝒂𝒏𝒊𝒄𝒔 or yellow mealworm, for feed production, we can use the larvae that could be interesting in terms of environmental enrichment, for example, in poultry farm. We can use meal. The meal obviously can be used also for food production. Actually, the species authorized for food production is yellow mealworm, while the �𝒂💏💂 is under authorization. But we can transform our larvae into meal and obtain also the oil from this production. And then we have some compounds that we will see later, such as, for example, the chitin. If we start to think about all the cycle from our waste to our products, it is important to consider what is the quantity of insect-derived products that we can obtain from our waste. If we consider 100% of our waste, we can obtain 25% of larvae biomass. We have to consider that the larvae biomass, the fresh one, is composed mainly from water because, for example, a larva is composed by the 30% almost of dry matter. So from this larvae biomass, we can obtain almost 8% of insect meal. And then this insect meal can be used as is it or can be defatted. And we can divide it through different processes, the dry process through, for example, through a press. And in this case, we can obtain a defatted meal that is rich in protein and a oil that is rich in fat. And this is the difference in terms of composition of the two types of products. The full fat meal, for example, is composed by a high crude protein, but also the quantity of fat is quite high. If we defat, we remove the oil, we can reduce the quantity of oil and in proportion increase the quantity of protein. Why is necessary this process? Because if we consider livestock animal, the quantity of fat that we include inside of the diets are quite low because at the end we would like to have a product that is less rich in ether extract, in fat, when compared to the protein. So to include the insect meal, it is important to reduce the fat content. In this way, we can include this insect meal in high quantity. And then we have the compounds that I said before that are important because could improve the animal health, but also the human health when you start to eat insects. For example, the chitin is a compound that increase and improve the innate immune system of the cell. And then we have also the antimicrobial peptide that can be used, and the research is focusing on the use of these antimicrobial peptides as alternative or antibiotics. It is important to consider that the antimicrobial peptides are the part that is innate of the immune system of insects. So the quantities of this compound change in relation to the insect species. For example, if we consider the 𒂊𝒂𝒏𝒊𝒄𝒔 that naturally growth on decaying organic matter, the quantity for antimicrobial peptide is quite high when compared to, for example, crickets. And so we can conclude our cycle and the production cycle of insect with the byproducts of the insect farm, that is the frass. The frass is the digestive substrate of the animals, and the standard of this frass is set by the European legislation. It is important to consider that this is a byproduct and not a waste because it is rich of NPK, so it can be used as a soil fertilizer to improve the quality. So there is really not a really waste of the insect production. So we have concluded all the production chain and also the life cycle of insects. I would like to thank you, and if you have any question, I'm here, or you can contact me by email.
Many
Thank
thanks,
you.
Sarah. Many thanks for your inputs, and you close the cycle very, very efficiently by indicating the plus, which is the new power in insect production. So we can keep the questions for the Q&A part at the end of this seminar. So we're moving now forward with the aquaponics part, with aquaponics and multisolver, back to the future. So we go from Feed the Future to Back to the Future with Michael Rader, who is a CEO in aquaponic manufacturer from Germany, and also Mercer Collins from the Applied Entomology and Applied Parasitology at Choice. So, Michael, you can go ahead.
Okay, thank you very much. Welcome to my presentation on aquaponics as a multisolver. For those of you, I'm Michael Reuter, as already said, and CEO of Aquaponic Manufaktur and part of the FrontAg Nexus project, and they're responsible for co-creating aquaponic solutions. For those of you who probably never heard of aquaponics, I try to just explain it in a nutshell and in a couple of sentences. Aquaponics is an agricultural production method that's based on the principles of circular economy. We combine aquaculture with hydroponics. That's why it's called aquaponics, because it's a circular production system that combines these two singular systems. Aquaponics is a closed loop process, and the connecting element between the different system parts is a process water. And as it is a closed loop, it consumes quite lesser water than, for example, arable farming or pond aquaculture. And it also discharges much less pollutants into the environment. That's why it's seen as a very sustainable food production method. The basic principle in aquaponics is water ecology. This means it's more or less mimicking what we know from typical aquatic biology that we can see in natural lakes, ponds, or rivers. As already said, we are combining recirculating aquaculture and hydroponics in a joint system. And the basic principle that makes this work is the nitrogen cycle. And as you can see in the graph here, the main input that we give into an aquaponic system is the fish feed. And the metabolism of the fish transforms this fish feed into feces. And the nutrients contained in this feces are transformed by bacteria from ammonia to nitrate and nitrate. And that's a very important nutrient for our plants. And the plants can take up the nutrients and thereby purify the water. And that's what makes the circle work. There are many different types of aquaponics that we can think of. The most simple way of doing aquaponics might be that we have a fish pond and we just use the water from the fish pond to irrigate nearby fields. But as this is not really a closed loop system or a circular system, we call this also sensulato aquaponics, because it's only in a wider sense really aquaponics. We just recycle nutrients that would otherwise be wasted and put them onto the fields, but we don't purify water and put it back into the pond in these systems. But in a narrower sense, there are also lots of different types of aquaponic systems. There are very simplistic systems that may be small and technical, not very sophisticated. They are oftentimes used for self-sufficiency or also for research projects. There can be larger systems that are only run seasonally. This is especially important in Middle Europe because there are large changes in weather and climate over the year. In other regions, seasonal aquaponics might be the same all year round. And there are also year-round aquaponics that are mostly large-scale commercial aquaponic systems that might use additional lighting when it's getting too dark in winter, or even heating if it's getting too cold. And which kind of solution is the right one for you depends largely on side factors like how many light do you have over the course of the year, how is the weather changing, and questions like these. The typical components of an aquaponic system at its core are, as already said, aquaculture and hydroponics. An aquaculture system, if it's a recirculating aquaculture system, like we prefer it in aquaponics because we want to recycle nutrients and water and everything, consists of fish tanks where we rear the fish themselves, but it also needs, in general, mechanical filtration that is used to get rid of solids that are harmful to fish if there are too many in the fish water, and also biological filtration. And that's the part where the bacteria come in to transform ammonia that is very poisonous for fish into nitrate and nitrate, which is much less poisonous, but anyways has to get out somehow of this aquaculture system. And usually we just replace a certain amount of water every day, but in a aquaponic system, we have hydroponics. And here also we have different systems that we can use to produce the plants, like media beds. These are production units where we fill beds with gravel and lead the water from the fish tanks through this gravel beds. And this is at the same time biological filtration, because on the gravel bacteria can live and transform ammonia into nitrate, as already said. And the plants that grow in the media bed take up the nitrate and also some of the ammonia to grow. And the very same we can do also with so-called deep water culture and nutrient film technique. And all of these are soilless techniques. This is very important because the plants grow only in some small amount of substrate, and the roots somehow take up the nutrients directly from the water. And after having been purified by the plants, the water can go back to the fish. And so we have a closed cycle. And that's aquaponics at its core. Oftentimes it makes sense to add additional loops to aquaponics. And the more you think about aquaponics, the more cycles you find that might be useful to add to aquaponics. Some examples are anaerobic digestion. There we can use fish sludge and also plant waste to be digested by other forms of bacteria. This largely improves nutrient use efficiency of aquaponic systems because a lot of nutrients can be found in the fish sludge that normally just is put out of the system. And also plant waste has a lot of nutrients that are very valuable for our system. So it makes completely sense to somehow make them available to our plants in the system. And at the same time, we can produce methane that we can use either in small-scale aquaponics for households, for example, to cook, or in larger-scale aquaponics to produce electricity and warmth that we might need for our system. And another example for a very useful improvement is insect farming, because here we can improve the sustainability of our fish feed. Oftentimes we have nowadays still a problem that we use a lot of fish meal in fish feed, and thus that's not very sustainable because of the overfishing of the oceans. And so we are looking into replacing some of this fish meal or as much as we can by producing our proteins that we need for the fish feed by insect farming. And at the same time, as already said by Sarah, we can produce additional organic fertilizer. So why are we talking about multi-solving when we're thinking about aquaponics? Multi-solvers are technologies that tackle several problems at the same time. And that's something that's in the face of climate crisis very important today, because we face so many global challenges that we really need to look into solutions that solve more than one problem at once. And aquaponics has exactly these multi-solving qualities. And as we can see here, we think that aquaponics address 10 of the 17 Sustainable Development Goals of the United Nations. That depends on the location where we look at. For example, Goal 11, Sustainable Cities. Their aquaponics is only relevant if we are building it in a city context, and that's not always the case. So not always all of these 10 goals are addressed by aquaponics, but usually a lot of them. 3 of the most important I would mention in more detail. Development Goal 2, no hunger. If you look at the pyramid here in this graphic, we see that traditional agriculture produces more or less everything that we have in our daily diet. And aquaponics also produce a large part of this, but no dairy products and also no carbohydrates. And that's why we say that aquaponics are only addressing what we call the hidden hunger. So malnutrition and not hunger that would be solved by eating more carbohydrates, for example. Then the goals 6 and 14, clean water and sanitation, and life below water. This is addressed almost always by aquaponics because we use so few water compared to traditional agriculture and also to open pond fish farming or ocean fish farming. And this is why this is always a huge benefit compared to these traditional farming methods. And also responsible consumption. If you're looking, for example, at nutrient use efficiency or the carbon cycle in aquaponics, we see that aquaponics can add a large deal to get to a more responsible consumption and production in this world. Normally, when I'm talking the first time to people about aquaponics, one of the first questions is what might be the performance of an aquaponic systems that we might aim for. And that's why I did this slide here with some rules of thumb for estimating economic viability of aquaponics. This is based on an example with African catfish and a hydroponics system with mixed vegetables, herbs, and leafy greens. Obviously, these numbers do not account for every aquaponic systems, but they strongly depend on local side factors. And this you always have to think of to have a better idea of what to await from aquaponics. You really have to look at the side factors at a given location and also at the size of the system and everything. But as a rule of thumb, we could say that we can produce up to 20 kilograms per meter square of production surface. This might be a greenhouse or just a shading net or open field, whatever. We can produce, if you're looking at catfish, 175 kilograms per cubic meter of production volume in the fish tanks. What would be the needs in means of electricity? There we can calculate about 7 kilowatt hours per meter square per year. And in the aquaculture, 350 kilowatt hours per cubic meter production volume aquaculture. The water use would be around 500 to 750 liters per meter square, largely depending again on side factors like evapotranspiration. And we would need around 250 small fish fingerlings per cubic meter in the aquaculture and 140 kilograms per cubic meter of fish feed. If you look at a rather small aquaponic system with 200 meters square greenhouse and a 4 cubic meter aquaculture, this totals up to about 4 tons of vegetables that we can produce per year, 700 kilograms of fish, and an electricity requirement of added up 2,800 kilowatt hours. 1,000 fingerlings needed, 560 kilograms of fish feed, which are the main inputs, and a water need of 125 cubic meters per year. And the workload would be about, well, let's say 2 hours a day. So we see that with 200 meters square of production surface, we can produce quite a lot of produce, and we don't have to put in too much resources. And that's why we think that also from a point of view, a balance of performance, aquaponics is quite interesting. Obviously, there are also a lot of challenges, but also available solutions in aquaponics. And if we're looking at the Mediterranean region, most important is probably sometimes electricity. In some countries, the reliability of the grid is not the best. We need investments for redundancy because the thing that is making our system run are water pumps and aerators, and they should never stop because otherwise either the fish might die quite quickly, but plants sometimes even die faster than the fish. And we have a large cost of procurement just for installations that we need for reliability of electricity. And one solution to this problem might be solar PV, or also the anaerobic digesters I was already talking about that can produce methane that we can use to produce our own electricity when sun is not shining. Another huge problem is water supply. Also the reliability, but oftentimes water quality is also a problem because we might have brackish water, for example, and also the cost of procurement for the fresh water might be quite high. And here a solution might be rainwater collection, because on a 200 meter square surface, like we were looking at in the slide before, we can collect a lot of water. And the third main challenge I would want to mention is fish feed, because of the poor sustainability of commercial fish feeds regarding fish meal that is oftentimes used in the feed. The feed quality is not always very good. And here also in some countries, the costs for fish feed is really high. And that's why it makes perfectly sense to think about how we can replace commercial fish feeds by something we produce by ourselves, like, for example, insect larvae with insect farming. Yeah, and that being said, I'm already done. Thank you for your attention.
Thank you, Michael. Thank you. So, yeah, that was a very interesting approach, because now, as it stands, we have what we call the endoponics, which includes also aquaponics, but also incorporates insects into the system. So everybody feeds each other, like insects feed the fish, and fish feed the residues of the fish feeds the plants, and then some plant residues go back to insects. So you produce frass that goes back to plants. So it's a very diverse circular economy system. Great. So now we are moving forward with the presentation of the 3 projects, which are the backbone of this this work of this webinar?
I'm so sorry to interrupt. We have the presentation of Mr. Collins.
Okay, yeah.
But
Yeah,
we're
yeah.
facing one minor technical issue. I'm trying to promote him as a panelist, but the invitation is being rejected for some reason. So if Mr. Collins would like to accept the invitations as we make him a presenter, that would be great. Otherwise, we could proceed, and then maybe later on, Mr. Collins could have his presentation.
Yeah, that was my thought, Ismini. Thank you, Ismini. Actually, Ismini is behind the curtains for this webinar. We're just giving the presentations. So I didn't see Dr. Collins here in the panel group, so I thought that it will be worth it to proceed with the next presentation. And then whenever Dr. Collins is connected, we can go ahead with the specific part, all right?
Yes, now he's joining.
Okay.
Now he's with us now. Perfect.
All right. So,
So,
which way to go? Do we proceed with Dr. Collins and then with? Okay. So, Dr. Collins, you can continue with your part for the aquaponics and the back to the future aspect.
Yeah, thank you so much, Christos. Am I audible? Hello.
Hello, we can hear you. We can hear you.
Yeah. Can you share your presentation? Perfect.
I'm sharing your presentation, Dr. Collins. So if you would like to start, let me know whenever you want me to change your slides, okay? I think we're having a technical issue.
Yeah. Looks like the sound is not. Yeah, should we perhaps we can proceed with the other part, the three projects, and then we can continue with Dr. Collins in case.
Yes, perfect.
Dr. Collins is able to be connected. Okay, so I will share my screen here. Let me just give me 1 second, and I am all right. All right. Okay, so can you see my screen? Can you see the presentation?
Not yet. Yes, now we can.
All right. All right, perfect. So I'm gonna be talking about CIPROMED, which is the project under the title Circular Inclusive Utilization of Alternative Proteins in the Mediterranean Value Chain. Actually, it's a very focused project to the residues in the Mediterranean area, which is unique in terms of both agricultural production, agri-food production, but also unique in terms of the residues and the byproducts and the different kinds of substrates that are practically discarded through these chains. So do you see the chain, the next slide now? That's the chain?
Yes.
All right. All right, so let's start from the very beginning. So practically we haven't realized that what we have eaten yesterday and what we are going to eat today and what we are going to eat tomorrow is heavily based by 75% from only 12 plant species and only 5 animal species. Just consider that we are heavily dependent on 17 species, 12 plant and 5 animal species, which is very important, especially in the case of plants, which are gradually utilized as food source for insect production. We heavily rely on the big 3, as we say, which is wheat, maize, and rice. So consider whatever happens to those 17 species, this is directly linked with global food security. This is a slide that I would like to share with people whenever I give some introductory approach regarding the insect farming. It seems that in Europe, we are going to have 2 major changes in the very next future, I mean, by 2050. Number 1, the European population is declining, expectable. Number two, the meat consumption in Europe is declining as well. But in all the other continents, both of those indicators are going up, which is something that we have to consider and think outside of our European bubble. Let me be more specific. Food waste. Food waste is a huge issue. And for us Europeans, we used to say that, okay, we are not that much food waste contributors, but no, 130 million tons is the food waste for the European Union people, which means that this corresponds to 1/5 of the Amazon, not the Amazon on the internet, the other Amazon in South America, which means that we practically through this food waste, we discard a lot of material that can be eventually cultivated and be brought back to the system. The other thing is that the more than 1 billion euros have been invested in the sector of insect farming, which is very, very critical. And the third point here is that within the pandemic, the European Union declared that annual meat production and annual meat consumption has been decreased from 55 to 49 kilograms per person. But in Asia, for the same interval, the annual meat consumption per capita per person, there was a huge increase from 30 to 35 kilograms per person. So consider those 200, 300 million of Europeans versus the 6 billion of Asians that are going all the more to animal products, to animal origin food. This means more, there is an increased need for more meat. So practically, this is what we do here. We're utilizing different types of byproducts. Those are some images of byproducts over here that can be used as food and feed, I mean, through insects as food and feed. And this is how those byproducts are working. This is the Tenebrio molitor larvae, the yellow mealworm larvae. And by using the different kinds of byproducts, eventually what you do is that you are accelerating its production. You are producing more larvae with high protein, larvae that are able to produce more eggs, which means that you are getting much more individuals that you can milk to get protein out of it. And not only that, here we are with the Laura from the University of Torino. In our FRAS experiments, Sarah developed very well the type of FRAS. This is one of the soil improvement agents that is expected to play a very key role in the European Union market in the very near future. It is already solved. It's already formulated by different companies in Europe and elsewhere. And of course, insects are utilized in a great way as feed. Here are some poultry experiments that we have carried out during the years with enormously good results. And so this is pretty much our project, CIPROMED, circular and inclusive utilization of alternative materials to produce different size streams and different value chains. Those are some metrics of the project. We have 17 partners from 10 countries, and those are the logos of the countries. But what I would like to emphasize here is that the problem is this: we don't want to import, as Europeans, the vast majority of our proteins from abroad. And I'm talking about soy meals. So the EU demand is to go for efficient, viable, and mostly locally produced alternative protein sources. So we have identified in this project 4 different protein sources: microalgae, legumes, like lupins, which for not that much lupin production in the European Union during the last decade, but it's getting bigger and bigger. Insects, which is our main area of expertise, and of course fermentation. How all those are going back to the system through fermented products and fermented chains. And this is the infographic of the project, how each ingredient of those 4 ingredients feeds the next level, and then the next level, and the next level. It is circles within circles within circles. So what we want to do is to produce 3 basic things. One is new food, the other is new feed, and the other is different diets to create those new food and feed items. Those will be done with specific feeding trials in predefined models, and also through specific trials with humans, like we have a university hospital of the University Hospital of Bologna as a partner in CIPROMED. So they are going to do some of the responses to specific groups of people through sensory analysis and through safety, regulatory compliance. Even we are taking into advantage the aspects regarding psychological, cognitive, emotional attitudes, the yuck factor when it comes to insects. And of course, we will develop a business model and several exploitation plans per product, per food source, per value chain. That's it from my side. Thank you for your attention. And I'm looking forward for the questions at the end of this webinar. Thank you.
Thank you so much. I think we may need to try again with Dr. Collins.
Perfect.
Can they try?
Yes, we can hear you. Do you want us to share your presentation, or are you going to share your presentation?
Oh, please share it for convenience.
Can you all see the presentation?
Yeah, very clearly. So my name is Dr. Collins Baresa from Egerton University. And my title of my presentation is Realm Black Soldier Fly Larvae for Fish Feed Formulation. Next. So as a university, we have a living lab. And this particular living lab in Kenya is tailored at is aimed at developing tailor-made solutions to local challenges within Nakuru City and its surroundings. So how do we achieve that? We hope to achieve that by the use of efficient solar energy management, food safety. We also address water quality, hydroponics, aquaponics, and as well as insect rearing. So and therefore that's why I'm actually interested in insect rearing as one of the segments. So then the question is, when you talk about insect rearing, which kind of insect do you have in mind? The insect that we have in mind is what we refer to as the black soldier fly, which is our insect of choice. So below there, we have an illustration where you're having the adult black soldier fly. Then next to it is we have the life cycle, which takes approximately 45 days. And why this particular insect? This particular insect is very important because then it can actually contribute to food security. It can also be used for organic waste reduction through biodegradation. And then from the frass, which has been said by my colleagues before, the frass is also very important as a soil nutrient and therefore contributing to improvement of yields and therefore reducing the cost of feed production and improving the livelihoods of people or rather the livelihoods of our communities. So what we have here is the integration between black soldier fly for circular technology and aquaponics. And when you look at this kind of an illustration here, then you have the life cycle. But then what's more important about this life cycle is nothing else other than the pupae or the pupa stage of this particular insect, which can be used in decomposition. So we have these illustrations right at the bottom where we have the red arrow illustrating a truck, which is offloading organic waste. The organic waste therefore can be broken down. And in the course of being broken down by the larvae, then we end up having the larval stage number 5, That larval stage is very important because it is rich in proteins, and that the proteins can therefore be harnessed to provide a source of protein which is required as a fish feed in an aquaponic system. So this is an aquaponic system where we have aquaculture, production of fish, but again, the resultant residue, the resultant water rich also in waste materials contain a lot of nutrients, which can be used to support plants in what you're calling an hydroponic system. Proceed. Next. So what we have here is a first figure, and this one is showing us the production, fish production, attributed to aquaculture and natural systems. So on one side, we have the first photograph, which is actually green, and that is showing a natural pond out there in the world where we can do aquaculture. But then now next to it, we have those two photographs within the graph. And what we can see is that we can see the boats. Then next to it, we can see a lady who is actually out there along the lake shore trying to dry the fish, which is actually acquired through capture production. But then the question is, if we're talking about fish, what does fish require? So fish is very important as a source of proteins to all of us, and that it has the following requirements. It requires, if we are to produce fish by either aquaponics or aquaculture, then it requires proteins, it requires carbohydrates, lipids, mineral, salts, as well as vitamins. But now what about in Africa, and especially for Kenya, where we come from? What are our sources of protein? Because sources of proteins are the most important in animal feeds and more so in fish feed. So as a continent, or rather as a region or as a country, our main source of proteins are basically fish meal, soybean meal, then we have canola meal, sunflower meal, maize meal, and then we also have wheat bran. Next. So whereas that is, those are the sources of proteins, it's very important for us to note that the source of proteins mentioned are very expensive. And why are they expensive? They're expensive because most of them can be used as food for human beings. So that means that if you are going to rely on those particular sources of food as a source of ingredients for fish feed, then it means that we are going to have a competition for the same food resource between livestock and human beings. So to alleviate that kind of a scenario, what happens that there is therefore need to explore alternative source of proteins, and more so proteins that are required in formulating fish feed by relying on what we are calling black soldier fly, whose benefits I've just mentioned. So what I have here with me is we have two tables, and these tables are derived from a study that I've done with my former master's students. This particular study, or these particular results, are actually under review. The manuscript is under review. But what's more important about these illustrations is that the purpose of this first table is to show you a scenario where we have the nutrient components that are required by fish, but then these nutrient components are found in black soldier fly depending on the type of feed substrates, depending on the type of feed materials that the insect was fed on. So we have three feed substrates. One was chick mash as a positive control, which is conventionally used here at the university to rear black soldier fly. We have Irish potato peels. These are food byproducts. Then we have the kales, and kales here, we have the kales, and then we have the bovine ruminant content, which were used as feed for the black soldier fly. Interestingly, what we have to notice that the crude protein here, therefore, ranged between 38 to 45% based, or therefore this variation was attributed to variation in the type of substrate used. Also, it's also important to note that the nutritional composition of the black soldier fly is significantly dependent on the type of substrate used for rearing. Proceed. So then we are talking about, therefore, if that's what you've seen, and especially with respect to proteins, although we also had other components, the question is, So then what's the role of black soldier fly larvae meal as feed in aquaponics? And the question is then, why are we using black soldier fly as a source of proteins? So by using black soldier fly larvae meal, it becomes very important because then it reduces the challenges of adopting aquaponic systems, especially in the tropics, by the following reasons: by minimizing high cost of feed or fish feed, which has already been said, because then it constitutes about 50–70% of the total production cost. 2, it reduces overdependence on fish meal as a protein source. And therefore, by depending on fish meal as a protein source, especially the tropics, what will happen is that our fish resources within the water systems are likely to be depleted because of competition for the use of fish as food and fish as a source of protein for animal feeds. By so doing, therefore, then this one therefore contributes to environmental conservation. And then I've said overfishing and use of fish as feed and food as feed instead of food. Then by using black soldier fly larvae, what happens that we are also going to have effective use of agricultural waste for clean, healthy environment. Because we are saying that we are going to use organic waste, we are going to use food wastes, which if discharged into the environment, then they will turn out to make our environment become unhealthy. And by so doing, this contributes to sustainable production of organic food, because from the decomposition process, we end up having the proteins for fish feed. At the same time, we have the frass, which can in turn be used to do what? Produce vegetables. But this is now with respect to what we are calling aquaponics. So the question is, locally, what are the locally preferred local species for aquaponic systems? So the 2 main species that we have is tilapia, what we refer to as 𝒂𝒂𝒑𝒐𝒏𝒊𝒄𝒔 niloticus, and then we also have African catfish. So currently, these are the 2 main local species of fish that are produced under aquaculture, or which can be produced under aquaponics. Next. So if these 2 are the 2 main local species of fish, then the question is, when you talk about rearing fish, probably in aquaponic system or in aquaculture, then there are several factors you have to bear in mind. And one of them, which is the most important, is the specific nutritional requirements of the 2 species of fish. So I have 2 tables here. The first one talks about the nutritional requirements. This is compounded for tilapia feed. And in that case, therefore, it depends on different stages we're talking about. So for tilapia, it requires between 25–35% crude protein. And you can see that if we are to use what you're calling a black soldier fly larvae meal, which I've just already shown you, you can see that the protein ranges, these ranges we're talking about, are within what can be provided by black soldier fly larvae. Then if we look at catfish, the crude protein requirement is between 30 and 45%. Again, this is within the range of the crude protein that was realized by rearing a black soldier fly here at the campus on different feed substrates, and which therefore in that case represented what you're calling food wastes. That clearly shows that actually we can use black soldier fly to produce the desired crude protein percentages required for the rearing of this particular species of fish, and therefore thereby reducing the cost of fish production. Next. So then the question is, if we need to formulate what you're calling a fish feed, which can support either the production of catfish or tilapia, what kind of knowledge do we need to have as a farmer? So if you have to go out there, because by the end of the course of the project, one of the things we have to do is that we have to do these particular experiments within the university, but then thereafter, this kind of knowledge that we're talking about must be taken out there to the community so that the community can actually embrace these technologies. They can therefore embrace these particular innovations to ensure that they produce more fish, which therefore will contribute food security and also improve their livelihood and therefore provide more income. So they need to have a knowledge of nutritional requirement of the fish that they want to rear in aquaponic system. They need to understand the physiology and biochemistry of the species that you have in mind, even before you think about feed formulation. They also need to know about availability and nutritional values of various ingredients used in the feed mixture, the chemistry of various nutrients and sub-nutrients. It's important. These nutrients we're talking about, we've got to know what role do they perform within the fish that we are supposed to produce as food. Then we have to note the role of different ingredients within the metabolism of either the catfish or the tilapia fish. Then the question is, what are the other dietary components? If we are talking about a meal, will it be a complete meal, or what else do we need to add so that the fish gets adequate nutrients to give us optimal growth and therefore give us optimal production? Then probably we also have to understand other factors like physiological and economical reasons before we get into it. So the point is, what are the different feed formulation methods? And the question is, why should we take a lot of time to understand different feed formulation methods? And the reason is simple, is because there is no single feed ingredient that can supply all nutrients and energy requirements for optimal growth. And that's what I was talking about, other additional ingredients, other dietary needs. So in this case, therefore, a mixture of feed ingredients is combined to produce a diet with the desired nutrients and therefore desired nutrient profile to give us the desired characteristics of the fish that we want to produce. In that case, therefore, there are several methods, but they can simply be broadly classified into linear programming method. And then we also have this other method here, which is also very important. And that's the Pearson square methods. So this is quite elaborate. I'll not get into that, but these are things that we discuss as we continue to interact in the next conference. Next. So let's talk about formulating an insect-based meal for aquaponic fish. And here what I have in mind is a meal where black soldier fly larvae is used as a source of proteins. But remember, it's not only just a source of proteins. I've demonstrated in one of my illustrations that it also contains a wide variety, a wide range of nutrients which are very important. So the qualities of a high quality fish feed should ensure the following. One, should ensure that it ensures optimal water parameters for fish and other essential parameters. The feeds that we want to talk about, the meal that we want to talk about, will automatically be dispensed in water where our fish lives. So the question is, how does it affect the water parameters? Are we talking about a feed which, if we release into the water, then it interferes with the physical, chemical parameters of water? The moment we do that, automatically will be out of the equation. The other point is nutrient requirements to both fish, probably plants that are found there, as well as other essential bacteria. And which plants am I talking about? I'm talking about an aquaponic system, which is coupled with hydroponics, where we assume that once the fish has gotten its nutritional requirements, the fish also ends up doing what? Releasing other waste, defecating into the water. Then all that comes out at the end of it all is supposed to be taken to an hydroponic system. So are we talking therefore, the question is, do we have a meal which therefore is adequate to provide, adequate in terms of providing nutrients for the fish and nutrients for the plants under hydroponic? Then the other point is that it must be nutritionally balanced for species-specific nutrition needs of different stages of fish. Remember, as the fish grows, it undergoes through different stages. Each and every stage requires a desired quantity of nutrients to bring about the desired expectations. Then proper size and texture of the pellets, and you're saying the surface of the pellets should be smooth, uniform and shiny, ensure high utilization rate, but in feeder feeds are automatically rough and dull. So we must ensure that we are providing the desired size and texture. Improved Milling enhances binding characteristics. How do we process the feed that we are talking about? How do we mill? And in the course of processing, we have to ensure the number of breakages should improve the hardness and water stability of the pellets. If you throw the pellets into the water, they're supposed to float so that the fish can capture them, the fish can ingest them. Are they going to remain stable, or are they going to break into smaller particles? It must have an attractive smell and taste. Palatable, stable, under storage. For how long can you store it after processing? Must have the correct size for swallowing. Are they too big? Are they too small? So the size also must be ideal for swallowing by the fish. It must bring about high feeding or high ingestion rates of different stages of fish. So another point is it must improve the feed conversion ratio, which therefore reduces cost to the farmer, and it should be free from impurities and contaminants. And that's why you'll find that in most African countries and the tropics, what happens that the quality of feed is normally a very, very big problem. For example, in Kenya, we have quite a wide range of challenges during the formulation of commercial feeds. And these particular challenges are simply arising because what we have is normally probably some of them are formulated on an experimental basis, and sometimes they're normally formulated without considering empirical information, probably gathered from what? Gathered from rigorous research. And that's why therefore we are on board to do the research so that we can actually therefore advise on high quality, on production of high quality fish feed. And then we also have a policy for production of certain feed are also a little bit weaker. And that's why we find that we don't have quality fish feed. Next. So then we talk about replacing fish meal. We've talked about the qualities of our high quality feed. So we've gone ahead to do experiments with the students. And I said that this work is under publication. And what has happened that we're replacing fish meal with black soldier fly meal in our aquaponics system. So what we have in the first diagram on my right is a simple setup for the experiment. And this is an experiment where we had 3 diets. So the diets that we had, or the treatments we had, was 0 black soldier fly meal. So this one contained 100% fish meal, which served as our positive control. Then we had 30% black soldier fly larvae meal and 70% fish meal, because now we are replacing. Then we had 50-50. So we have 50% black soldier fly larvae meal and 50% fish meal. Then the question is, what were our results? So we looked at these results from 2 perspectives. One, we looked at the effects of these particular treatments or experimental diets on water quality. Remember, I said that a good and ideal fish feed should ensure that the water qualities remain stable. And the water parameters that we looked at were temperature, pH, conductivity, ammonia, nitrates, and the concentrations of nitrates. In this particular table, on the extreme right, we have the p values. And you can see that in all the cases, the concentrations and the 3 different types, the diets had no significant effect on the water parameters, implying that the water parameters therefore remained stable. Next slide. Then we also looked at the performance of the African catfish fed on black soldier fly larvae meal in aquaponics, in the same system we're looking at the water parameters. And why catfish? For this particular study, we chose catfish because, unlike tilapia, it can withstand. It's a relatively more hardy fish as compared to tilapia. So we thought, therefore, it would become easier for us to begin with this hardy fish, probably to give us what you are calling preliminary results. So we looked at various parameters. That was the weight gain, the specific growth rates, the feed conversion ratio, the feed intake, and the change in length. And you can see that when we look at the effect of treatment or diet in this case, where we are using the first diet with a 0% black soldier fly larvae meal, what as our positive control, what emerged is that again, there was no significant difference, implying that they can actually replace what we are calling fish meal. We can use black soldier fly. We can use black soldier fly larvae meal to replace fish feed. Next. Next. Then to sum on that, because this was an aquaponic system, then it was very important to follow up and see the water that came from the aquaponic system where we are rearing fish. How effective can it be used for production of vegetables? And the type of vegetable that therefore we produced under this kind of conditions was lettuce. And in lettuce, we measured these particular parameters, and we growth parameters, total fresh weight, total dry weight, leaf weight, root weight, dry weight, leaf dry weight, root dry weight, number of leaves, and root length. And indeed, these are the kind of results that we saw, and that treatment type had a significant effect when we look at it with respect to total fresh weight of the plant, as well as a fresh leaf weight. Otherwise, these other parameters remained more or less constant. These other parameters were not significantly affected, and therefore point potential of actually improving on our study to use what we are calling black soldier fly larvae as a meal.
Collins, I'm afraid we cannot hear you. I don't know if you can hear me. Maybe we're having a technical issue again. I see that Dr. Collins left the webinar. So I suggest we shall proceed. Next, we're having 𝒊𝒏𝒔𝒂𝒑𝒐𝒏𝒊𝒄𝒔 from the University of Turin for presenting us the ADVAgromed project. So Ilaria, please, you have the floor. Thank you.
Thank you very much for the introduction. Can you hear me well?
Yes.
Okay, that's great. So good afternoon, everyone. My name is 𝒊𝒏𝒔𝒂𝒑𝒐𝒏𝒊𝒄𝒔. I am a veterinarian and a researcher in animal nutrition at the University of Turin. And today I have the pleasure to be here in presenting you our project, which is the ADVAgromed project. I know that we are a little bit late on the schedule, so I will try my very best to save some minutes for the next speaker. So the first question that we have is, who are we? Because I think it is important to introduce ourselves to the participants of the webinar. The ADVAgromed project involves a total of 7 different partners, 6 from the European Union, and in particular, I am referring to 2 partners from Italy, 1 partner from Spain, 1 from Greece, 1 from Germany, and 1 industrial partner from Portugal, which is the endocrine insect company. And we also have a partner from the extra European Union, which is a partner from Morocco region. Second important question, which is the scope of our project? Actually, when we have to deal with insects, the answer is always very clear and logical. Everything falls within the concept of circular economy. And this is also something that you can easily deduce if you simply look at this picture. Basically, what we would like to do in our project is to valorize and reutilize the agricultural side streams to feed live insect larvae that in turn will be administered to local poultry breeds. In addition, considering that we don't like very much having some waste in any kind of production processes, we will also try to reutilize the side streams of the insect farming and the poultry farming. So basically, I am referring to the insect grass and the poultry manure as fertilizer for the crop production. So in this project, we are able to apply a concept of from waste to farm, because from waste materials, we are able to obtain two high-quality products, which are the live larvae on one hand, and the insect grass and poultry manure on the other. Last but not least important question, how is the project organized? We have a total of 6 work packages, and apart from the classical work packages that we basically identify in any kind of project, so I'm talking about the coordination and management work package, or the dissemination, exploitation, and communication work package, in this very brief presentation, I would like to focus my attention on the so-called scientific work packages of the project, which are the work package 2, 3, 4, and 5. And let's start with the work package 2, local agricultural byproducts as substitute for insects, which as in the University of Thessaly in Greece, the leader. This kind of work package has 3 main goals. First of all, we would like to identify, collect, and nutritionally analyze the byproducts that are locally available in every country that participates into the project. And based on the nutritional profile and the availability of this byproduct, we would like to formulate optimal diets for the 2 most important insect species that Sarah mentioned in the first presentation of the webinar, which are 𝒂𝒒𝒏𝒊𝒄𝒔 lucens and 𝒂𝒂𝒏𝒊𝒄𝒔 molitor. And as a third goal, which is, in my opinion, the most challenging one, we would like to perform a mass rearing of the insect larvae on the diets that perform the best. And when I am referring to the best diets, I'm talking about the best diets in terms of performance and bioconversion efficiency of our larvae, and of course, the nutritional profile. Why do we need to mass rear our larvae? Because the larvae will be used in the work package 3, local poultry breeds fed live insect larvae, which sees in the University of Turin its work package leader. In the work package 3, we are going to focus our attention on 2 types of poultry strains, which are the egg type strains and the meat type strains. And in particular, in the group of the egg type strains, we are going to work with an Italian breed, which is the Bionda Piemontese, and 1 Spanish breed, which is the Pita Pinta. While when we focus our attention on the meat type chickens, we are going to work with a local Greece turkey breed and a local Moroccan breed. The most interesting part of this work package is that the live larvae will not be used as environmental enrichment, so will not represent a supplementation, but will actually enter into the diet formulation. And this is something that has been explored very little so far by the scientific community. And basically, the live larvae will enter into the diets being included at 5 or 10% on dry matter calculated on the daily feed intake of our animals. And in all the poultry trials, we are going to evaluate some specific parameters. We will focus our attention on the bird performance, the animal welfare and health status, and of course, the quality and the consumer acceptance of the final products, eggs or meat. Moving on with the work package 4, this work package 4 will collect the frass and the poultry manure from the previous work packages, and this work package is under the leadership of the National Research Council in Italy. And in particular, we are going to utilize the yellow mirror frass from Italy and Greece and the black sturdy flies from Portugal. And of course, we are going to utilize the poultry manure from all the partners that will be involved in the poultry trials. So basically, Italy, Spain, Morocco, and Greece. And depending on the different country, we will focus our attention on different local varieties of vegetables. In Italy, we will work with the tomatoes and brassicace. In Greece, the colleague will work with pepper and eggplant. In Spain, with the brassicace and maize. And finally, in Morocco, with onion and barley. And as a final aspect, not because it is less important, but because chronologically it is the final aspect on any kind of actually analysis in this kind of testing something new, we are talking about the work package 5, which is the environmental and economic impacts and consumer acceptance of novel farming systems, which as work package leader, the German Food Technology Institute. Even in this case, we have a total of 3 main goals. First of all, we are going to characterize and perform the life cycle assessment and the life cycle costing from all the data that we collected in the previous work packages. We will also focus our attention a little bit more on the consumer side of the project. So basically, the social life the social life cycle assessment with a strong focus on the ability and the predisposition of the consumers to accept this kind of novel products obtained from animals fed live larvae. And as a final aspect, we hope to be able to identify the optimal production scenarios and, most importantly, to be able to develop some efficient sustainability communication strategy with the stakeholders. And before concluding and thanking you for your attention, this is a summary of our social media. We have a website. Here you can see the link, but also the QR code if you want to immediately access to the site. And we also have two social platforms, which is Twitter and LinkedIn. So if you have any questions or if you are interested into the project, please feel free to contact us. Thank you for your attention.
Thank you so much, Lara. It was a very nice presentation and it's a very nice project, very interesting. We will proceed with the question next after my presentation. I don't know if Dr. Collins would like to add something because we had to stop him because of the technical issues. Dr. Collins?
Yeah, thank you so much. It's unfortunate that the network disappeared, but indeed I was actually on my last slide, if I'm not wrong. So I believe it was visible. And then my second slide was on about references. So that was my last slide. Next. So those were the references. Then finally, that was my final slide. And I want to say thank you so much for your attention. And we look forward to having such kind of interactions. Thank you so much.
Thank you so much as well. And our apologies for stopping you there. We thought we lost you for a minute, but it's good that it was your last slide. So I think now it's my turn to share my presentation. Is my presentation visible by everyone?
Yeah, it's visible.
Okay, perfect. Thank you so much. Thank you so much. So good afternoon, everyone. My name is 𝒊𝒏𝒔𝒆𝒊𝒏𝒈, and I'm project manager at FoodScale Hub. A few words about FoodScale Hub. FoodScale Hub is an impact venture studio working to accelerate the shift towards tech-enabled innovations in the agri-food sector. Today, I am very excited to present and share with you the journey of FrontAg Nexus, a project that was born from a simple yet profound question. How can we boost the capacity of populations in the Mediterranean to adapt the challenges posed by climate change and population growth? Having that as a starting point, it guided us to the development of FrontAg Nexus. FrontAg Nexus is a 3-year project starting from May 2023, so it's almost 1 year of implementation. We have a consortium of 10 partners spanning to 8 different countries. FrontAg Nexus represent an effort to advance sustainable agriculture practices in the Mediterranean region and beyond. Our aim is very clear: addressing the complex challenges at the UEFA Nexus, increase the resilience of populations that are dependent on the agri-food system, and showcase the impact of frontier agriculture. Now, one really important thing that we need to clarify and we need to reply is, what is the UEFA Nexus? So, what is the frontier agriculture? That is the next question I'm going to have. So frontier agriculture, that is our cornerstone for our project, represents a shift in farming practices through the innovative application of hydroponics, aquaponics, insect farming, vermiculture, vermicomposting, and agro-photovoltaic. Frontier agriculture offers circular and simplified technologies that enhance resource efficiency and sustainability. By transcending traditional agricultural methods, frontier agriculture holds the promise of addressing pressing challenges, such as food security, while alleviating pressure on scarce resources. So if that's not a bold statement of mine, we're not just talking about solutions, we're talking about promises for sustainable future. Now we need to address the 𝒂𝒂 Nexus. So what is the 𝒂𝒂 Nexus? 𝒂𝒂 Nexus highlights the connection of water, energy, food, and ecosystem. By embracing integrating approaches to resource management, FrontAg Nexus seeks to navigate the intricate web of interdependencies essential in the 𝒂𝒂 Nexus. Our holistic approach acknowledges the imperative of balancing competitive demands to ensure the long-term viability of our natural and human systems. Having said that, we reach to the objectives of FrontAg Nexus. As you can see, our objectives are twofold. First, we need to demonstrate, we're aiming to demonstrate the socioeconomic and ecological impacts of the 𝒂𝒂 Nexus approach, and second, to promote the adoption of frontier agriculture for improved livelihoods and resource management. By focusing on the Mediterranean regions, where, as you can imagine, the challenges of the 𝒂𝒂 resources are more severe, we're trying to make a positive change and to foster resilience in populations and communities that are vulnerable. Now, concerning our implementation approach, is characterized by multi-actor engagement, interdisciplinary approach, and capacity development. Through demonstration cases in Italy, Israel, Jordan, Morocco, Tunisia, and Turkey, we seek to bridge the gap between theory and practice, fostering innovation and knowledge exchange at local and regional levels. By fostering policy coherence and cross-sectoral collaboration, we aim to create an enabling environment for sustainable agriculture. Now, if we wanted to take a closer look, we see that there are many different countries involved. That means that we have diverse climates, yet we have common goals. Our demonstration cases, if I could say, are like windows into the adaptability of our innovations. Through monitoring and evaluation, we are gathering valuable data and insights into the feasibility, scalability, and impact of these innovative solutions. Each demonstration case has different demonstration pilots where we use different frontier agriculture practices. Now we want to go a bit to the actual things that we've achieved so far. As you can see, we're having many activities that we've done, like building a greenhouse for hydroponics in Tunisia, having a play for simplified hydroponics in Morocco, having an open incubator for insect farming in Italy, a fish tank ready to be used in Israel, and a raised platform for photovoltaic system in Tunisia. However, all of our partners are working relentlessly, and more updates are coming up with, for example, building more photovoltaic systems, more greenhouses, indoor vertical hydroponic systems, and so on. Let's see now the expected results of FrontAg Nexus. As you can see on the left side of your screen, we have a very big list of what we're expecting to achieve. For example, we're expecting water use efficiency up to 90% in hydroponics and aquaponics compared to conventional farming. We're expecting to achieve a 33% increased availability of fish protein through RAS aquaponics compared to conventional farming. Although I'm not gonna overload you with all this information, because I would like to just point out what are the FrontAg Nexus expected impacts that are manifold, ranging from improved livelihoods and food security to enhanced socioeconomic resilience in the Mediterranean regions. By generating best practices, our project aims to inform policy making and empower communities to adopt sustainable agricultural practices. Through collaboration and shared learning, we aspire to create a lasting change and pave the way for a more sustainable future. However, we're not doing this alone. We believe in teamwork. That is why, as we embark through this journey of FrontAg Nexus, we invite you to join us in advancing sustainable agriculture for the benefit of present and future generations. So that I'm going to ask you to follow us in all of our social media accounts, register to our Knowledge Hub community, and share your thoughts there, talk to our experts, and discuss on the frontier agriculture practices that we're having. Subscribe to our newsletter and be the ones to know first about our results and activities. And of course, stay tuned for more from FrontAg Nexus. Thank you so much. And now it's the time to move to the Q&A session. Just give me 1 second. Okay. Perfect. So if anyone would like to pose any question, please feel free to raise your hands, and I will give you, I will grant you permission to ask your question. As I see, we have 2 open questions here in the chat. So the one is very easy and I can respond to it. They ask us if we could please have the presentations. Yes, we are recording the meeting, thus the recording will be available through the social media of each project, so you will have access to the presentations. Another question is from Lauren Charles, saying, my question is for the project managers and representatives. Are there any practices, tools, ideas from the other 2 projects that you think would be helpful to your own project? Say, for FrontAg Nexus standpoint, is there anything from CIPROMED that you think could improve how you're doing things? So maybe Gertrude would like to take the floor. Is our coordinator in FrontAg Nexus. So Gertrude, please.
Yeah, thank you very much. Actually, that's a very good question. And I think I have to answer with yes, because when I was listening to the presentations of the colleagues from the other projects, I really found it exciting that they are doing experiments with feed from insects, not just in relation to fish, but also to chicken. Because I believe probably raising chicken for rural or for farmers is maybe easier, especially in regions that are prone to drought, than raising or rearing fish. And Michael is here, so in our proposal for this project, we had included chicken, but in the end, we were so far concentrating on fish. But we have started and are almost at the end of our first survey. We are interviewing, as Ismini showed you, people from our case country or sites, yeah. And this was a very open interview to find out also about preferences for, let's say, climate smart and water saving agri-food technologies that are not within our basket of technologies. And we are just starting with analyzing the data. But for instance, if we find that many of the respondents say something about feed and chicken, then of course we would start talking with the partners whether we shouldn't take up this as an additional prototype in the project. So to close my long answer or finish up my long answer, I liked especially the idea about with the chicken and weighing the chicken and checking and comparing it with other feed. So yeah, I would like to do that too. And Ismini was already promised a chicken or a turkey.
That is true.
So
Unfortunately, Mr. Athanassiou is no longer with us. He had an issue with his internet connection. That was the one that promised me the chicken. So hopefully, his colleague, Mr. Rubos, maybe he will work through our,
We will remind him.
our promise. So are there any other questions? Any of the attendees wishing to ask anything?
Also with your own voice, we can open your mic up for you.
Yes.
Another thing, while we are waiting for questions, another thing that I find really interesting in webinars like this is the different approaches to a similar problem or to a joint problem, let's put it that way. And that's the beauty of research, that different people have different ideas and go about them in a different way, still aiming for a common goal. And then the combination of all the answers to all the questions might give us better clues on what to do in the future. So this is also why I like this webinar with 3 similar but yet distinct projects very much.
I don't think anyone has a question. I don't know if any of the panelists has another. Okay, no, we're having a question. So, Christina, please feel free to give us your question.
Hello, and thank you for the presentations. They were really interesting. I have a question concerning the legislation in Europe concerning insects. And I was wondering if it's legal to use live insects for feed. For which animals? As far as I have heard, it's fish and chickens. And which insect species are allowed in Europe up until now to be utilized?
Thank you, Christina. Very interesting question. I think Sarah mentioned something about legislation in her presentation. So Sarah, if you want to take the floor.
Yeah, thank you. Thank you for the question. So in Europe, it is possible to use live larvae for fish, but also poultry and swine. But it depends on the state inside of Europe if they have a law about it. For example, in Italy, we can use live larvae from September 23. Before was not authorized. And I think this is the answer. I don't know if you ask also about what are the insect species that are authorized, if I understood well. Yeah.
Yeah,
And,
insect species and which animals also, which livestock.
Yeah. Yeah, it depends on the type of products derived from the insect. So if we think about live larvae, we can use it for all the animals, with exception of ruminants. But it depends on the law of each country inside of the Europe. So it is possible in Europe, but for example, in Italy, it is possible from last year. If we consider, for example, protein, it is possible to use it in aquaculture or in poultry, swine, but it's not possible to use it in ruminants. And the oil is the one that is authorized for all the species mentioned. So it depends on the type of products.
Perfect. Thank you very much.
You're welcome.
Thank you, Christina. Very nice question. And of course, Sarah, for answering. Are there any other questions? I don't think, oh no, Ben, of course, Ben. Give me 1 second. Ben, please share with us your question.
Yes, thank you so much for this presentation. My question was to Collins from Edgerton. So from his statistics and the result he presented with the black soldier fly mixture in fish feed, the fish conversion ratio was a bit less efficient compared to the conventional feed. Is that a bit of a setback, or why was that? So from the slide, we saw that without the black soldier fly where it was 0, it was more efficient compared to so we need more to get 1 kilo of feed, obviously from the black soldier fly, which makes sense. But this difference, is this something we should be worried about, or because it's quite minimal? What would he say to that?
Yeah, thank you so much. As far as we are concerned, this is just a preliminary study. And these are some of the things that we are still considering, because remember, the aim of our study is, first of all, we want to begin with semi-field experiments done in a greenhouse. Then once we optimize, and now we have a proper solution, then at the time, therefore, we can release the results and discuss with members of what? The communities, the local communities around the university, and the local communities around the adjacent towns. So this is still a study which is still under development. What I've just presented are simply preliminary results. But once we come up with that solution, then automatically I'll be happy to share with you.
Thank you so much, both. I don't know, Ben, would you like to follow up with another question, or?
Since this is preliminary, I think it's good because it would help other projects on black soldier fly, especially in the tropics. I'm looking forward to it. I don't know if the boss wants to add anything.
Yeah, I would like to add a question, because it's really nice to have also a sub-Saharan African country among the panelists or representatives, not the country itself. But I mean, I give you a similar question to what I got, namely listening to the presentations of the other two experts on insect farming, you being from Egerton in Nakuru. What do you think about their technological approach, and would that work for Egerton? Or how does your technological approach differ from what you saw from theirs?
Mr. Collins, can you hear us?
Yeah, but
okay.
You are thinking, that's good.
Yeah, I can get the question, but you are saying the technology approach compared to what? Sorry.
I mean the production and conversion of the larvae or into fish or into feed. So
yeah, conversion. Yeah, the use of the use of the larvae into feed, because basically much of what we've done, and I'm happy that someone talked about poultry, because for poultry it has always been very easy, because as a tropical country, and someone has talked about drought and time coming when they're not fed. You know, poultry sometimes becomes easier because then you can do what? You can throw the live larvae, the poultry, and they eat. But now you see, for this kind of a case here, what happened that you really have to harvest the larvae, dry them. Then we have this machine that can do what? Can do pellets. So what happens that we do pellets, so that once you have done the pellets, and remember these pellets here are for experiments, then we began by starting with the pellets. So what we are trying to do, that we are trying to mimic the feeding habits of the fish, where we throw the pellets on the water and then they jump on the surface and pick the pellets.
But for instance, I think Sarah said they separate the oily part from the dry part with the insects, right?
No, it's just whole insects. But
you take the whole of the insect.
Yeah, just the whole insect you crush, and then now you mix the feed and you formulate pellets.
Okay.
Then you throw into the water. Yeah. So we are this particular level where we are simply using the whole insect. But
okay.
Those are also some areas that would be nice for us to consider as we move on.
Okay. Okay.
Thank you so much. Very interesting questions and answers, of course. I don't know if there's anyone else wanted to have a question, because I see we're almost 20 minutes late of our actual schedule, but it's okay. It was very interesting webinar, and thank you all. So unless there is no other question from anyone, I believe we can finish today's webinar and give our promise to have the next webinar very, very soon. So, okay, no more questions. Thank you so much, everyone, especially the presenters. It was a very nice webinar, very informative one. Hope to see you all very soon. And many thanks to the participants that stayed that late with us. So thank you so much.
Yeah,
Thank you. Bye-bye.
Bye-bye.
Bye.
Bye-bye.
Bye.
See you. Thank you.
Bye. Thank you.
Bye-bye.